All right, this is Module 11, Skill Builder number 7, and it's a little bit of help with dealing with square roots, cube roots, that sort of thing. All right, so just to remind you, 2 squared is basically you saying 2 times 2, and that's going to be 4. 2 to the third is 2 times 2 times 2, and that is 8. Well, if you want to go the opposite direction, the square root of 4 is 2. Why? Because 2 times 2 is 4. The cube root of 8 is 2. Why? Because 2 times 2 times 2 was 8. All right, so we know that these work out. Square root of 4 is 2. Cube root of 8 is 2. So we get something that's a nice whole number. Well, could you take the cube root of 4? And the answer is yeah, you can. Could you take the square root of 8? Can you do that? Yes. But the problem is your answer is not going to be a rational number. In other words, you're not going to be able to express that number as a ratio of 2 integers. Let me pull up my calculator and I will show you what I am talking about. Okay, let me expand my window just a minute. Hang on. Okay, so cube root of 4. Let me see if I remember how to do this. I want to do the square root, I'll do the square root of 8 first. Square root of 8, enter, and you get this big long number, and there's even more decimal places, I'm sure, but they're just going to give you this first couple. Okay, well, what about taking the cube root of 4? I think it's on the math list. Yes, it is. All right, so I'm going to do cube root of 4. Again, I get a big long decimal that doesn't repeat or terminate. Both of these are irrational numbers, okay? Because I can't take those numbers and express them as a fraction of 2 integers. Okay, so I can still take the square root of 8 and I can still take the cube root of 4, but it's not going to be a whole number anymore. Okay? If it is not something that you can express as a ratio of 2 integers, then you are dealing with an irrational number. Okay, these are irrational numbers. The 2 here, that was a rational number because you can express that as like 2 over 1. It's a ratio of 2 integers. All right. So basically, if it isn't a perfect square or a perfect cube or what have you, it's going to be an irrational number. The square root of 2 is actually one of the ones that I asked you guys to memorize. The square root of 2 is 1.41, and then it just keeps going. It's irrational. Okay. Square root of 3 is going to be similar. .73, and the decimals keep going. It's also irrational. Okay. 10 is going to be irrational. I already know that because 10 is not a perfect square for any number. Like nothing times, I don't have any numbers that say that number times that number gives me a nice even 10. So square root of 10 3.16, but again, it doesn't repeat or terminate. I can't express it as a ratio of 2 integers. It's going to be irrational. 80 is not something that is a result when you square something. So for instance, 9 times 9 is 81, but 8 times 8 is 64, so neither one of them square to give you 80. So the square root of 80 is going to be another irrational number. Okay. Okay. I can also, instead of representing the square root of 80 as 8.94, I can factor out some things. I know that 80 is 8 times 10, which is really 2 times 2 times 2. and then 10 is 2 times 5. Well, 2 times 2 is a perfect square. And another 2 times 2 is a perfect square. So I can take the square root of 4 out, and that's 2. Square root of another 4 out, and that's another 2. So really, I can write this as 4 times the square root of what I've got left, which is 5. But still, if it's times the square root of something, it's still irrational. Okay. All right, what about this one? This says the square root of 3 times the square root of 3. Well, square root of 3 squared. And you're going to get 3. So you're back to what you had before you did anything. Square root of 11 times the square root of 11. Oops. You're going to be back at 11. So this is a rational number. This one's also a rational number because I can express it as a ratio of 2 integers. Okay, so we've got this next one, and this says the square root of 5 to the third power. Literally, that says square root of 5 times the square root of 5 times the square root of 5. Well, square root of 5 times square root of 5 gets you back to 5, but then you're multiplying that by the square root of 5. So all you can do is just say it's 5 times the square root of 5, and because there's a square root in it that's not a perfect square, this is irrational because you cannot express it as a ratio of 2 integers. Okay, square root of 72. I know that 8 squared is 64, and I know that 9 squared is 81. 72 sits somewhere between 8 squared and 9 squared. So I know it's not going to be a perfect square, so I already know that this is going to be an irrational number. I can do it on my calculator to get the decimal equivalent. 72, 8.485, blah, 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 blah. Keeps going. Okay, but I can also factor out 72. 72 is 9, which is really 3 times 3, times 8. 8 is really 2 times 2 times 2. Oops. Okay. Well, 9 is a perfect square, so I can take the square root of 9 and I get a 3, and that comes out of the radical. 4 is a perfect square of 2, so I can take the square root of 4 and I wind up with 2. So these two can come out of the radical, but I do have one thing left. So square root of 72 can also be written as 6 times the square root of 2. Okay, I'll prove it to you. 6 times the square root of 2. Enter, and see you get the exact same answer as when you took just the square root of 72. Okay. All right, the next one says the square root of 6 squared. Well, 6 squared is 36. So basically you're saying, what is the square root of 36? Well, the square root of 36 is 6. Technically, it could be negative 6 also, but they didn't have a negative 6 in here. So square root of 6 squared is just 6. Square root of 200. Again, I know that, let me see, 16, no, not 16 squared, let's see. 13 squared I know is 169. 14 squared is 196. 15 squared is 225. So square root of 200 sits between 14 squared and 15 squared. It's obviously not going to be a perfect square. So when I take the square root, I am going to wind up with an irrational number. 200. Enter. Yep, something between 14 and 15. So I can put the decimal, or I can factor it out. 200 is 2 times 100 100 is 10 times 10, and each 10 is 2 times 5 times 2 times 5. Okay. So 5 squared is 25. Take the square root. I can bring a 5 out. 2 squared is 4, so take the square root of 4. I can bring a 2 out. 2 times 5 is 10. And we've got this little 2 left in there. Square root of 2. Okay. All right, square root of 27. Don't let this one fool you. You might look at 27 and be like, oh, yeah, it's 3. No, the cube root of 27 is 3. But there is no perfect square number that will give you 27. Okay, so this, again, is an irrational number. But I do know that 27 is 3 times 3 times 3. I can take a square out. So 3 times 3 is 9. The square root of 9 is 3. I'm running out of room. Okay, so this one, when I write it out, that can be 3 times the square root of 3. But since it's got a square root part, it's still irrational. Okay? We already did the square root of 8. Remember, 2 times 2 times 2. I can take out 4. The square root of 4 is 2, but I still have another 2. So the square root of 8 is 2 times the square root of 2. 5 times the square root of 2 squared. Ooh. 5 times the square root of 2 times 5 times the square root of 2. Well, 5 times 5 is 25. Square root of 2 times the square root of 2 is just 2. 5 times the square root of 2, all of that squared, is 50. And it's getting sloppy in here because I'm running out of room. All right, so I'm going to leave off the last 2, but I hope you've kind of gotten an idea of how to do those.